So today's topic is differential equation and the formation of the differential equation. The definition is an equation which involves the differential coefficient is called differential equation, that is dy by dx d2y upon dx2 or d by dx of d2y upon dx2 and del 2u upon del x del y, etc. For example, if we form the differential equation, then the differential equation will be like d2y upon dx2 minus 5 into dy by dx plus 6y is equal to 0. This is a simple differential equation, this is the ordinary differential equation. And if we talk about partial differential equation, then it will be like del 2u upon del x2 minus del u upon del y is equal to 0, something like that. And there are two types of differential equation, that is ODE, which is the ordinary differential equation. That means the differential equation involves the single independent variable is called ordinary differential equation. It means dy upon dx plus y is equal to 0. It is a simple differential equation. It contains y as a dependent variable and x, this is a independent variable. And the other differential equation type of differential equation is a partial differential equation, which involves more than one independent variables. That is and the example of the PDE is like del 2u upon del x2 plus 2x y and into del 2u upon del y2 plus 6 into u is equal to 0. This is quite difficult differential equation in the form, but this is PDE. And in the differential equation there are two main terms, that is called order and degree, which is basic fundamentals of the differential equation, any type of the either or PDE or ODE. So the order of the differential differential equation is the highest differential coefficient present in the given differential equation. That is, it means how much times we differentiate the dependent variable with respect to the independent. And the other term is degree of freedom. Degree of freedom means the power of highest order differential coefficient present in the differential equation, but after removal of the radical sign. Radical sign means the negative power raising on the differential equation and the fractional powers. So if we have to calculate the degree of freedom, then we first the degree of the differential equation, we have to see the radical sign firstly, that is the negative powers or fractional powers. For example, a simple differential equation d2y upon dx2 plus 6y is equal to 0, and then we have to find out the order and the difference degree. So the y is dependent variable and the x is independent variable, and here y is differentiated with respect to x 2 times. So the order of the differential equation is 2, but the degree. By the definition of the degree is calculated only from the higher order differential coefficient. So the degree of this differential equation, that is the degree and power of the highest order differential coefficient, which is 1. If we take some more examples, second is d2y upon dx2 plus y whole raised to the power 1 by 3 is equal to d3y upon dx3 plus dy by dx whole raised to the power 1 by 4. So here we have to calculate the degree of the differential equation. So we rationalize the powers and then we get multiply simply whole power by 4 here and 3 here. So it will be d2y upon dx2 plus y whole to the power 4 and is equal to d3y upon dx3 plus dy by dx whole to the power 3 simply. And if talk about the order and the degree, then the order is the highest order of the differential present in the differential equation. So here this is the highest order differential coefficient, hence the order of the differential equation is 3, but the degree is also the highest power, that is power of the highest order differential coefficient. That is here is it only double derivative, single derivative, third derivative, so order will be 3, and the power of this differential coefficient, that is the degree. So if we open this differential equation as assuming a plus b to the whole cube, then highest power will be 3. So this is the degree of the differential equation. And if we take more examples of the order and the degree, such as let dy by dx plus d2y upon dx2 whole to the power minus 1 by 2 and is equal to 1 plus d3y upon dx3 whole to the power, and simply let us take it d2y upon dx2 and the power will be minus simply plus 1 by 3. So we have to calculate the degree and the order. So simply replace the radical signs. So 3 and 2 will be exchanging, so it will be dy by dx plus d2y upon dx2 to the power minus 3 is equal to 1 plus d2y upon dx2 whole to the power 2. So remove this term from here to there, right side. So 1 is equal to, so quite simply, so dy by dx plus d2y upon dx2 whole to the power 3 into this term will be in the right side already d2y upon dx2 whole to the power 2. And the order of the differential equation, that is how much times differentiate the dependent variable with respect to independent, is only 2. So here and here. and the degree, if we talk about degree, then we highest degree in this term is 2 and in this term is 3, but we here multiply these two terms, the power will be added, hence degree is equal to 3 plus 2 will be 5. These are the basic concept of order and degree in the differential equations. And now we have to form the differential equation if a simple equation is given in the form of dependent and independent differential equation. Then the formation of the differential equation is quite simple. That is, here we have to remember that the number of arbitrary constant present in the differential equation eliminated is equal to the order. That is, if the two variables, if the two arbitrary constants are present in the differential equation, then the order of the differential equation will be only 2. It means if there is one arbitrary constant, then we have to calculate only once the given equation, and if we have two arbitrary constant, then maximum times we have to derivate. It means that is 2 times we have to derivate the given simple equation. So here for example, y is equal to ax plus a square, so we have to find the differential equation of this curve. That is, this is a linear, that is y is equal to mx plus c, where a is the arbitrary constant, but it repeats, so only one arbitrary constant is here. So we have to first differentiate the given equation with respect to variable, independent variable, that is x. So dy by dx is equal to a x is 1 plus constant 0, and here we find a is equal to dy by dx. But the differential equation is obtained only when all the arbitrary constants are eliminated. So simply we got the value of a, so put the value of a in the given curve. So we get y is equal to x into a, that is dy by dx, plus a square, that is dy by dx whole square. So this is the differential equation, that is ordinary differential equation. And hence here if we observe that the order and the degree, so order is 1 and degree is 2 from this term. And one more example. So here the two arbitrary constants are present, so maximum number of times we differentiate the equation, that is the only 2 times. So firstly we simply differentiate the this equation 2 times, and then we observe the result. So firstly with respect to x, dy by dx is equal to a, and cos to the integral differentiation is minus sin x plus b into cos x again. So again differentiate the given equation, so d2y upon dx2 is equal to, simply put here minus a, and differentiation of sin x will be cos x, and plus differentiation of cos x is minus sin x. So if we common minus sin, so we get a cos x plus b sin x, and this is what the given equation is y, so it will be minus ka y. So d2y upon dx2 will be minus y, and both the arbitrary constants are removed. So this is the differential equation of the given curve, y is equal to a cos x plus b sin x. Now take 1 and 2 more examples of this type of the simple differential equation. So here we simply got the equation like this. So here are three independent variables, that is a, b and c, and so we firstly differentiate the given equation 3 times, so we get some results, and we manipulate these and eliminate the arbitrary constant a, b, c. So firstly differentiating the given equation with respect to x, so y square, that is 2i and of the y dy by dx is equal to a, and differentiation of x square will be 2x and b into x to 1 and c, that is 0. Again differentiating at least 2 times, so here we observe 2 functions, then first into second will be applied, so we get 2 times, here put first and into my second d2y upon dx2 plus second, that is dy upon dx and dy by dx, so it is equal to a into 2 times x plus this, the integration of this term will be 0. So here we got n 2 into 2, so is equal to 0. This is the second term, so we got y into dy upon dx2 plus simply multiply these, so dy by dx whole square is equal to a, and this x, the differentiation of x will be 1, so this is replaces by 1, and again finally, so put here first and in second, so finally first and the differentiation of second will be this d3y upon dx3 plus put here the differentiation of first and take second as it is, this is second, this is first, and this the difference of the second, simply apply the power rule, so power will be in front and reduce one power, then multiply this differentiate this term, so d2y upon dx2 is equal to the constant of differentiation of constant is 0. So here all the arbitrary constant a, b, c are eliminated, so this is the differential equation of the given curve, and so this is the result. And the last problem of this topic is the family of straight line passing through the origin. So that is, we have to find out the family of straight line. So the line which passes through the origin is the form of, in the form of y is equal to mx plus c, where m is an arbitrary constant. If we change the value of m, then many number of straight lines will be formed, that is the family of straight line will be formed. So we have to find out the differential equation of the straight line passing through the origin. So here only one arbitrary constant is, so differentiate the equation only once, so that is dy by dx is equal to m into 1, that is m is equal to dy upon dx, but the arbitrary constant is still present, so we put the value of m, that is arbitrary constant, in the given curve, so we get the y is equal to m, that is dy by dx into x. If we solve this, so we simply got the differential equation in the type of y into dx minus x into dy is equal to 0. This is the some more concepts are here, and the trick to solve the simpler equations in more easy way, that is form 1. So if the given curve is like y is equal to a times some function fx plus or minus b times some function gx, and we have to calculate want to calculate the differential equation, then this determinant is useful. That is, the first column is filled by y arbitrary dependent variable, then its derivative, then its double derivative. Similar, the first function and that its a derivative and a double derivative, like that, and equate it to 0 and solve this. So take first example of this type. So here we fill this determinant, so y prime, y double prime. So we get and replace all and rest the arbitrary constant and no means in the determinant. So only fx and gx are taken, that is these a and b are, and forget. So fx, that is e to the power 2x, first differentiate to 2 times e to the power 2x, and again it differentiates 4 times e to the power 2x, like gx e to the power x, first differentiation and second differentiation will be same, so is equal to 0. And if we take common this and this, so we get e to the power 2x into e to the power x, and the determinant y prime, y double prime, 1 2 4 1 1 1, and simply expand it. So e to the power 3x, these are the two terms combined, and the simplification of this is y into, simply multiply these, so 2 minus 4 minus 1, this one, and y prime minus y double prime, and last term for 1, this one be the 4 times y prime minus 2 times y double prime. This goes to 0, so doesn't mean anything, so simply removed, and the term, so solve it, so we got the answer simply. And the second form, this is that is best result, and if the differential equation is of the form y is equal to c1, that is some constant, into exponent that is e to the power alpha x plus c2 e to the power beta x, like so. So this is the result, simple. So replace the given equation like this and solve, where d is the differential coefficient. So take it like simply y is equal to c1, that is like c1 e to the power alpha x, where alpha is 3, and here if we take beta, so beta is 1. So it should be written as d minus alpha. Take it, if this is positive, then put here minus sign. If it is negative, then the negative and negative will be positive. So if d minus 3 into this term, d minus 1 into y is equal to 0. If we solve this simple algebraic function, so d2 minus 4d plus 3 times y simply, and is equal to 0. And if we operate y in all the term, so d2y minus 4 times dy plus 3y is equal to 0. And this simple, this is the second order differential coefficient, y double dash, it should be written as y 4 times y dash plus 3y is equal to 0. So this is the result, and thank you.